Friends, today we are going to study electric flux density. So Michael Faraday, he conducted an experiment. He took two concentric spheres like this, a inner sphere and a outer sphere. He kept the charge in an inner sphere and measured the charge present on the outer sphere. Between two spheres, he kept some dielectric. Dielectric in the sense insulating materials like vacuum or any other thing. Okay, he observed that charge placed in the inner sphere, okay, same amount of charge is present in the outer sphere also. In outer sphere there was no charge. After placing the charge in the inner sphere, the same charge will be appeared on the outer sphere. So from that he concluded that, so once again I read it. Michael Faraday performed the experiment on electric field. He had a pair of concentric metallic spheres. Faraday found that the total charge on the outer sphere was equal in magnitude to the original charge placed on the inner sphere, regardless of the dielectric material separating the two charges. He concluded that there is some sort of displacement. Okay, so some sort of displacement has occurred from the inner sphere to the outer sphere, even though there is an insulating material in between them. Okay, which was independent of the medium of, we refer that as electric flux or displacement flux. So because of this electric flux, imaginary field, because of that one, what happens, the charge present in the inner sphere has occurred on the outer sphere. Okay, if the inner sphere is having a charge of plus q, the total charge present on the outer sphere will be equal to q but opposite sign, so that is minus q. If you place a positive charge at the inner sphere, I will get negative charge at the outer sphere. Okay, if I place negative charge at the inner sphere, I will get positive charge at the outer sphere, but the magnitude of the charge remains same. So because of the effect of the flux, some imaginary field displacement, so that one we call by the name as a electric flux. Okay, if the electric flux is denoted by a symbol psi and the total charge on the inner sphere by q, then by Faraday's experiment psi can be written equal to q. Psi total flux is equal to q, and the electric flux psi is measured in coulombs. Similar to your charge, your psi is also, that is the electric flux is measured in q. Okay, so now we'll go for electric flux density. If we consider an sphere, we will consider an inner sphere of radius a and outer sphere of radius b. Inner sphere is having a charge of q and outer sphere is having a charge of minus q. Then the electric flux or displacement flux will be look like this. Means there is an electric flux or displacement flux moving in this direction. Radially the flux are moving. The path of electric flux psi extended from inner sphere to outer sphere is as shown in the figure. The net flux, if I consider some surface in between these two, so the in between two spheres there is an dielectric present in between the spheres. Somewhere in the between the dielectric, at some point, if I place some surface, okay, and if I measure the total flux passing through that surface, okay, the net flux passing through the surface we call by the name as electric flux density, and in another words we can tell that the net flux passing normal to the unit surface area is called electric flux density. Okay, so the net flux passing through normal to the unit surface area is called electric flux density. The magnitude of the electric flux density at any point on the surface is indicated by d, which is equal to total flux divided by the surface area S. Total flux psi divided by the surface area of S. That will give us the electric flux density at any point on the surface. Okay, because it is indicated by displacement flux, it is nothing but a displacement flux. For that reason they have symbolized as d. Okay, D here it indicates displacement flux, but usually we call it as an electric flux only. Okay, so this displacement flux or electric flux is given by the formula total flux divided by total surface area. The surface area of a sphere is given by the formula 4 pi r square. R is the distance from the center of the sphere to the point where we are measuring in the dielectric surface, or where we are measuring a point of measure is present. Okay, so D is given by the formula Q divided by 4 pi r square. Okay, the unit vector, now have to see the direction. This is the magnitude. If I want the direction, we can observe that if I take any surface, the electric field of that surface will be normal to the direction of the surface. So the unit vector which is normal to the surface here is r, that is ar, which is nothing but the direct, it is unit vectors in a direction of an radial vector. So radial vector is there, so the vector which is going in radial direction, so in that direction only our unit vector is also present. So for that reason here the direction is an is given by the value ar. Okay, thus in a vector from electric field density, a point which is at a distance r from the point charge q is given by q divided by 4 pi r square into ar, is coulomb per meter square. Okay, now we will derive a relation between D and E. D here electric flux density, E is your electric field. Okay, so electric field and D is the electric flux density. You know electric field, I once again repeat what is electric field. Electric field is nothing but the force per unit charge present at an point of measure. Where we want to measure the field, there we are placing one unit charge, and the force experienced by the unit charge at that point we call by the name as electric field. Okay, intensity. Here the electric flux is nothing but the flux at that point. So total number of electric flux present at that point. At that point, how many number of electric fluxes are moving? So that is given by electric flux density. Okay, now let us relate both of them. E is given by the formula, that is electric field is given by the formula Q divided by 4 pi epsilon naught into r square into ar, and electric flux density at a displacement r from the point charge q is given by D is equal to Q divided by 4 pi into r square into ar. So if I divide equation 1 and 2, it looks like this. Okay, so we'll get an value of 1 by epsilon naught, q everything will cancel, only 1 by epsilon naught will be remaining, and after rearranging, so the value of D is given by q epsilon naught into E. So epsilon naught is nothing but a permittivity of free space in general. Okay, if I consider free space is present between the two spheres, then this is the case. If some other than free space, if any other dielectric is there, so in general fashion I can give D is equal to epsilon into E, where epsilon is given by epsilon naught into epsilon r. Epsilon r is nothing but a relative permittivity. Okay, you have to remember this formula, it is very important. D is equal to epsilon into E. So now we'll go for a problem. Find D in the Cartesian coordinate system at a point P is equal to 6, 8, minus 10 due to three cases. One is we are measuring an electric flux density at point P, which is situated at 6, 8, minus 10 in Cartesian coordinate, due to three things. One is a point charge of 40 millicoulomb at origin. Second is a uniform line charge at rho L, which is equal to 40 microcoulomb in z-axis, and a third one, a uniform surface charge of density rho S is equal to 57.2 microcoulomb per meter square on the plane x is equal to 2. We will see one by one. First we will take a point charge of 40 microcoulomb at the origin. So the point charge is present at your origin, and the measuring point is present at 6, 8, minus 10. So first we will calculate the unit vectors are your unit vectors at P and 0 O. The vector at P is given by rp is equal to 6ax. Position vector of at p is given by rp is equal to 6ax plus 8ay minus 10az, and the position vector of r0 is given by 0ax plus 0ay plus 0az. The distance vector r is given by rp minus r0. Okay, from the point of measure to the point where our field is present is given by rp minus r0, and after simplifying, the vector r is given by 6ax plus 8ay minus 10az. The magnitude of distance vector is given by square root of x square plus y square plus z square. So say 6 square plus 8 square plus 10 square, which is equal to square root of 200. If I take if we want a unit vector, ar is given by magnitude of your r vector divided by magnitude of the r vector. R vector is 6ax plus 8ay minus 10az divided by magnitude of r vector, which is 200. So square root of 200 have taken. So now we will substitute all those things. So E is given by 1 by 4 pi epsilon naught A by r square into AR. So first we have to calculate E, then we can calculate D. So what I have done in order to avoid the simplification, so we can directly substitute the formula in D. So D is given by epsilon naught into E. So 1 by 4 pi epsilon naught Q divided into AR. Epsilon naught and epsilon naught get cancelled. Okay, 1 by 4 pi, and after substituting and simplifying, we'll get this as an answer. Okay, so next we'll go for second thing. If the electric flux density due to a line of charge, where the line is present, the line is present at in z axis, the line is present along z axis. Any point in z axis, if I take z axis is having a value 0x 0y and some point in z. Okay, any point in z can be written as 0 comma 0 comma 1 0 comma 0 comma 2, like that. Okay, depending on the position where our point is present on z axis. In general, I can write it as 0 comma 0 comma z. But the electric field along z axis, if I consider, so the field due to along the z axis, that is the vector, unit vector along the z axis, the value we can neglect it, or we can consider it as 0, because of the symmetry, the infinite line is there. So the vector due to positive z axis and the vector due to the negative z axis get cancelled. Okay, because of the infinite line, the vector due to positive and vector due to negative z axis get cancelled, and only we will get the vector due to x and y. In simple words, if we are considering the line on z axis, I have to neglect the z coordinate. Okay, and we have to take other two coordinates. So here the z coordinate, the point of measure on the z axis is 0 comma 0 comma z, and the point P is given by 6 comma 8 comma minus 10. As I told you, I have to neglect the z axis. If I neglect the z axis, only two other axes present. So RP is given by 6ax plus 8ay, and R0 is given by 0ax plus 0ay, and after simplification we will get the value of R is equal to this. Now the formula for E is given by rho L divided by 2 pi epsilon naught into R. So R we have calculated, just substitute the value of R and AR and simplify, you will get some value. You can take D is equal to epsilon naught into E, so epsilon naught also get cancelled, and after simplification we will get the value of D is equal to like this. Okay, so lastly, if I take a uniform sheet of charge, the sheet of charge is rho s is given by 557.2 microcoulomb per meter square on a plane x is equal to 12. So we have taken a sheet of charge. X is equal to 12 means it indicate the sheet is present at x is equal to 12. It indicate it is in parallel to y and z axis, because only x value is there, y and z value is not there. It indicate the plate is present parallel to y and z axis. If it is present parallel to y and z axis, the field normal to your y and z axis is ax. So I have to take ax as an unit vector which is normal to our z axis. Okay, so it may be plus ax, means it may our unit vector can go, or our vector can go in positive x direction or in negative x direction, because positive x is also perpendicular to your yz plane and negative vector is also perpendicular to your yz plane. So which one I have to choose? In order to see that one, we will see the value of x. The value of x of the point of measure, the value of x at point of measure is 6 here. So this 6 is less than 12. It indicates the point we are measuring is present below our sheet. Because it is present below our sheet, our this one unit vector or the vector should move in opposite direction. That is, instead of plus ax, it is minus ax. So in short, we can see that the point of measure is present at 6 and the sheet is present at 12, and 6 is less than 12. For that reason, I have to take an is equal to minus ax. So, and the formula of E is given by rho s into 2 epsilon naught into an. An is the only thing I have to calculate, because by using this x is equal to 12. Okay, so an we calculated, that is the direction of our unit vector is present in towards the negative x direction, so minus ax. So now if I put this value in d is equal to epsilon naught into e, epsilon naught also get cancelled, and after simplifying we get d is equal to minus 28.6 into 10 to the power of minus 6 coulomb per meter square. Hope you understood. Thank you.